So this video we're going to be talking about zero and negative exponents. So just looking at a little bit review, if we think 3 to the third, that's going to be writing it out the long way, 3 times 3 times 3. So then if we did 3 times 3 is 9, 9 times 3 is 27. So if we wrote a to the fifth out the long way, it's going to be a times a times a times a times a. Just means that there's 5 of them multiplied together. So 2 to the fourth is 2 times 2 times 2 times 2. There's 4 of them. So if we do 2 times 2, we get 4. 2 times 2 is 4. Now we got to multiply these together, so we should get 16. Negatives. Okay, so this 2 represents that there's 2. Since it's in parentheses, that means we're going to be doing this whole thing twice. So we're going to do negative 4 times negative 4. Okay, negative times a negative is a positive, so we're going to get positive 16. Okay, so now we're going to do this one. So we're going to get negative 2 times negative 2 times negative 2 times negative 2 times negative 2, because there's 5 of them and it's in parentheses, so we do everything that's in the parentheses. So negative 2 times negative 2 is 4. Negative 2 times negative 2 is 4. And then we still have this last one down here. So 4 times 4 is 16. And then we still have this times negative 2 down here. So negative 16 times negative 2 is negative 32. Okay, let's do this next one. Got negative 1 times negative 1, negative 1, negative 1, because there's 4 of them. Negative 1 times negative 1 is 1, 1. So 1 times 1 is then 1. Okay, this last one is written 3 times. Okay, so negative 3 times negative 3 is 9. And we still have this last negative 3. So positive times a negative, we should get negative 27. So what we can see here is whenever we have an even number like this and we're multiplying negatives, we should get a positive answer. So like this one here, we had an odd number, so 5. So we got a negative answer. Okay, we have an even number, so we got a positive answer. We had an odd number, got a negative answer. Okay, so whenever we're taking something to the 0, this is one of those little weird ones where it's going to equal 1. Anything to the 0 power is going to be 1. Okay, so even if we have a bajillion, it's still going to be 1. So anything to the 0 power is always 1. Okay, negative exponents. Whenever we have a negative exponent, I know some of you guys think of the bunk bed method. Okay, so whenever we have a negative exponent, we need to drop it down below. So we're going to get 1 over 2 squared. That's going to make it positive. Okay, so then 1 over 2 squared, we're going to take that 2 squared, so that's over, so that equals 2 times 2, which is 1/4. And you can plug this into your calculator. You can do the 2, and then there's a little caret button, and then type in negative 2, and you should get 1/4. So whenever you have a negative exponent, always flip it to the opposite side. So we flipped it to the bottom. So this next one, we're going to flip to the bottom. Then the exponent becomes positive. Okay, and then that is negative 3 times negative 3 times negative 3. Okay, so then we know it's going to be odd because it's an odd number. Or we know it's going to be a negative because it's an odd number. So negative 3 times negative 3 is 9. And we still have that last negative 3, so we should get negative 27. Okay, 1 to the negative 6 is 1 times 1 times 1 times 1 times 1 times 1. Okay, so we should get 1 because it's 1 over 1, which is still 1. So whenever you see a negative exponent, flip it to either the opposite side. So if it starts on the top, it needs to be flipped to the bottom. If it starts on the bottom, it needs to be flipped to the top. Okay, evaluating exponential expressions. Okay, so it's the same as if we just have numbers. We could have variables in these situations, and then we could plug numbers in for the variables, but none of our answers can have negative exponents. You never want to have an answer with a negative exponent. You always want to simplify it the furthest it can go. Okay, so we're going to look at this one. We have a negative exponent, we need to get rid of it. So I say you flip it to the bottom. Okay, now we can reduce this a to the 0 because we know that always equals 1. So 5 times 1 over b squared is the same thing as 5 over b squared. Okay, this one, we have a negative exponent, so we need to drop it down. So I get y cubed, and you only drop the thing that has the negative exponent. So there's my final answer because nothing else can be done. Okay, this one we need to move up top. So we're going to get 8x y squared over 4. Well, 8 over 4 can reduce to 2x y squared. Okay, this needs to go down because it's a negative exponent, so we're going to get 6 over a squared r0. Well, we can reduce this r0 to 1 because anything to the 0 power is 1. So we're going to get that, in which case my 1 just goes away. So there's my answer. Okay, I would suggest pausing the video here and then attempting these, and then I'm going to go through them. So I'll give you a couple minutes where you can pause it, try them out, and then you can see how I did them. Okay, so we have, these are negative, so we're going to drop them down. So we're going to get 4 over a cubed b squared. Okay, this one needs to go down, and so does this one. So he needs to go down, he needs to go down, and he needs to go up. So let's follow my arrow. So I got n to the 4th going to the top, k squared going to the bottom, and b cubed going to the bottom. Okay, looks like this 4 to the negative 2 is going up, and this x to the negative 1 is going down. I suggest writing arrows because I think it's easier to see what you're actually moving and what you have left. So we dropped this x to the 1 and y squared. Okay, so 2 squared is 4, because it's 2 times 2, and 4 squared is 16. Okay, so 4 times 16 then is going to be 64 over xy squared. Okay, so now this one, we know we need to move it down. This we automatically know is going to cancel because it equals 1 because it's to the 0. So we're going to have, well, what do we put on top if we're moving this a squared down? Well, we still have this 1 up here. There's always a 1 there. Then we have 3r squared a squared. Okay, evaluating exponential expressions by substitution. So this is going to be the same thing that we've been doing. So let's go ahead and reduce it, and then we'll plug this in. So this we know needs to go to the bottom. So we're going to get x to the 4th over 3 squared, which is the same thing as x to the 4th over 3 times 3, which is 9. Okay, so now I have it all the way reduced, so I'm going to plug this x equals negative 2 in for x. Whenever I plug it in, I'm always going to put it in parentheses. Always, 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 because it's going to make a difference. So we're going to put it in parentheses. So this is the same thing as negative 2 times negative 2 times negative 2 times negative 2 over 9. So negative 2 times negative 2 is 4. Negative 2 times negative 2 is 4. 4 times 4 is 16. So we're going to have 16 over 9. So we're going to have 16 over 9 as our final answer for that one. Okay, so this one we got to move up top. So once we move it up top, it's going to be 8r. There's nothing on bottom, just s squared. And then we're going to plug in our values. So r is 4, so we're going to plop him in for r. S is negative 2, we're going to plop it in there. So 8 times 4 times negative 2. Again, always put it in parentheses. Okay, negative 2 squared is 4, so we got 8 times 4 times 4. And that is 128. So there's my answer for that one. Okay, r to the 0 is still 1, so we just have s squared for this one. Plug it in. So we're going to have negative 2 squared. Again, put it in parentheses. Negative 2 times negative 2 should be 4. Okay, this one, we have a negative, so we need to drop it down. So it's going to be 36 over r squared. Let's go ahead and plug our r in. So we're going to have 36 over negative 6 squared. So 36 over negative 6 times negative 6 is 36. 36 over 36 is 1. So these ones are both negative, so we're going to flip-flop them. So it's going to be s squared over r to the 1. And then we're going to plug in our r and s. So our s is 3 squared, and our r is negative 6. So 3 times 3 is 9. And you can reduce that if you'd like. Okay, story problem. A population of marine bacteria doubles every hour under controlled laboratory conditions. The number of bacteria is modeled by the expression 1,000 times 2 to the h, where h is the number of hours after a scientist measured the population size. Evaluate the expression for h equals 0 and h equals negative 3. So let's do the h equals 0 first. And we're going to stay with that one in red. So we're going to plug in 0 for h. 2 to the 0 is 1. So 1,000 times 1, because that's 1, is just going to be 1,000. Now let's plug in h equals negative 3. So we're going to get 1,000 times 2 to the negative 3. We got to drop him down. So we're going to have 1,000 over 2 cubed. Well, that's the same as 2 times 2 times 2, so we're going to get 1,000 over 8. And then you can reduce that.